Hi you guys, today we're going to work on chapter 7.1, okay? This is about the interior, which is inside angles of a polygon, and the exterior angles of a polygon. Those are basically the two big things that we're learning. It's not crazy hard or anything. It could get a little bit tricky, but not too bad. First, we'll talk about what is the diagonal of a polygon. But to do this, let's talk about consecutive vertices. Each point, each vertex, these are called vertices, right? Vertex, each one is a vertex, plural is vertices, okay? Consecutive means in a row or adjacent next to each other. Okay, so if I call this a polygon A, B, C, D, E, vertex A and B are consecutive vertices. A and B are consecutive vertices. So you know what they mean. If they're non-consecutive, they're not next to each other. They're not in a row. Okay? So vertex A and C are not consecutive vertices. Okay? So when we talk about a diagonal, it is the segment that connects two non-adjacent vertices. Segment connects two non-adjacent vertices. Okay, it has to be two non-adjacent, and let me show you why. Okay, colored pencils. Here we go. Okay, if I go segment AC is a diagonal. Segment AD is a diagonal. Okay, I cannot draw segment AB as a diagonal because it doesn't go across anything. AB, not a diagonal. Okay, I could go B to E, that's a diagonal. B to D is a diagonal. C to A, C to E, those are all diagonals. Okay, so a diagonal is a segment that connects two non-adjacent. Okay, equilateral polygon. Everything we do is going to be convex polygons. You really don't need to worry about that word, but I'm going to show you what it is in case you see it. Convex means each corner sticks out. Okay? If it's concave, you've got a side that smashes in. This is concave. We are not doing concave. Everything will be convex. Okay, equilateral polygon. Equilateral, equal sides. You guys know that equilateral triangle, all the sides equal. All sides same length. Okay, all the sides are equal. We mark it. This is equilateral, right? Each side, they're all the same. Same length. Okay. Equiangular. All the angles are equal. Measure. Equal angles. Okay. All angles have the same measure. And you guys know that. We'll mark them with curves. These are all marked with one curve, meaning each angle has the same measurement. Okay, a regular polygon, that means that it is equilateral and equiangular. That's what the word regular means. All the sides have the same length. All the angles have the same measure. Okay, so those are just some vocab, some terms that we have to know. Now these theorems, these are the only two theorems that we have, okay? And then we just practice. That is it. I'm going to flip my paper over for a second and explain. Okay, we'll come back to the chart. If I have a triangle, we always say the golden rule of a triangle is the sum of the interior angles, the sum of the measures of the angles is always 180. So if I call this angle 1, 2, 3, measure of angle 1 plus measure of angle 2 plus measure of angle 3 is 180. We call that the golden rule of a triangle. So let's use this rule. This is a big deal. Let's use this rule and draw a different shape. Okay? If I have this shape and I want to know the total, I don't know each angle, but the total sum, like this is 180, what would be the sum of all these together? Well, pick one vertex, and I could divide this shape, this convex polygon, into two triangles. So I've got four sides, but I've got two triangles. I know the sum of these angles is 180. I know the sum of these angles, 180. So when I have two triangles, four sides, two triangles, 2 times 180, my total is 360 degrees. That's for all the angles added together, right? Four sides, 360. Four sides, two triangles, 360. Let's try another one. Instead of four sides, let's do five sides. Okay? Pick any vertex. Does not matter which vertex I pick. I'll pick this one. Let's draw diagonals. So we are connecting non-consecutive vertices. This time I've got five sides. I've got three triangles. So if I add this angles, right, and then the rest of this, these, right, 180, 180, 180. Three triangles, 3 times 180. $540 degrees. Okay? So if I have three sides, I've got one triangle. If I've got four sides, I've got two triangles. If I've got five sides, I've got three triangles. And we could keep doing this. Okay? And when we draw this, each time you're going to see the number of triangles is 2 less than the number of sides. So in this case, I've got 1, 2, 3, 4, 5, 6 sides. I can see I've got 1, 2, 3, 4 triangles. So this time it's going to be 4 times 180, which is 720. Okay? So to get the total of this, we've got to get 4 and multiply it by 180. I've got to get this number 3, multiply it by 180. I've got to get this number 2, multiply it by 180. This number 4 comes from the number of sides. So if I go 6 minus 2, multiply by 180. 5 minus 2, which gives me 3, times 180. Okay? 4 minus 2 times 180. So the formula to find the interior, the total, the sum of the measures of the interior angles of a polygon is going to be the number of sides, subtract 2, and then multiply by 180. So flip this back over. So right here, polygon interior angle theorem, the sum of the measures of the interior angles of a convex polygon, and all we're going to talk about are convex. So we really, I guess, but just to know there are other kinds, okay? The sum is equal to the number of sides minus 2 times 180. Okay? The sum equals the number of sides, goodness, sorry, that's a B, number of sides minus 2 times 180. Another thing to watch, okay, the number of sides is equal to the number of angles. And I'll show you what I mean on that. It's just something to think about. It's also equal to the number of vertices, because the angles are at each vertex. So in this picture here, okay, I've got 1, 2, I'm going to talk to the number of sides. 1 side, 2 sides, 3 sides, 4 sides, 5 sides, 6 sides. There are 6 sides. I can see I have 6 angles. And that's the vertices, right? These points. There's 6 vertices. Just something to note as you're working. Okay, if I want to find, you do not have to draw this. I am drawing this, only for conceptual understanding. Okay, so I've got the sum is equal to the number of sides minus 2 times 180. So I've got, we already said, 6 sides. So this is the sum is equal to 4 times 180, which is equal to 720. Okay? And the reason why, again, would be if I picked one vertex, doesn't matter which one I pick, I draw in all the diagonals from that one vertex. You only do it one time. Okay, the idea is to split the polygon into triangles, divide it into triangles, and I've got 1, 2, 3, 4. I've got 4 triangles times 180, 720. I will do some other kind of practice with that problem, but right now that's good. That's all we need. Okay, and then the last one. Okay, the exterior angles. When you only do one angle at each vertex. Now you are not going to do this. Oh, I don't have a pencil, I don't think. Okay, don't draw 2. You don't draw 2 angles. So like on this one here, if I have a shape, I only draw one angle. I don't also extend the other side, okay? You just extend one side at each vertex. One side at each vertex. It doesn't matter which one you extend. These angles are equal measure because they're vertical angles, but you only do one of them. So as long as you only do one at each vertex, so this is 1 angle, 2 angles, and it's always 3 angles. Which one do you want? 4 angles, 5 angles, right? So I've got 1, 2, 3, 4, 5 sides, and I've got 1, 2, 3, 4, 5 exterior angles also. Okay, I just wanted you to see what I'm talking about. You only do one angle at each vertex. So when you do this, the sum of the exterior angles, the sum always equals 360. Always. It's always 360. It's just like the measure of the interior angles is always 180. Exterior, always 360. And that's with one exterior angle at each vertex. Okay? You guys, that's it. That's all you got to do. So I'll do some practice with you and we'll get some stuff going. I'm not going to do them all. The sum of the measures of the interior, so we just want the sum. So I've got 1, 2, 3, 4, 5, 6, 7, 8. I expect you guys to stop it and you try it, okay? And so you stop at any time. Don't just do what I'm doing, please. Oops. Okay, so you're going to go 6 times 180. So in this one, 180 times 6, right? And again, that's because that's a number of triangles. If I were to pick one vertex just from one, drawing the triangles, I've got 8 sides, and I've got 1, 2, 3, 4, 5, 6 triangles. Okay? This one you guys can do if it's an n-gon. You're going to do the same logic. I'm not going to do the whole problem. Number of sides minus 2 times 180. This tells us how many triangles we have. N minus 2 is the number of triangles. So then it's going to be 9 times 180. Okay? Keep going here. Now this one, these problems are a little different. I'll do just a couple. Okay? It says, use the polygon interior angle theorem to find the value of x. Well, this is 4 sides. I know the sum, so I'm going to start with the sum. 4 sides, so the sum is equal to n minus 2 times 180. The sum equals, right, 4 minus 2. So 2 times 180 equals 360. So the total of all of these angles is 360. Okay? So we're going to go ahead and we're going to add angle plus angle plus angle plus angle equals 360. That's all we're going to do. So I'm going to have 108 degrees plus 121 degrees plus 59 degrees plus x equals 180. And you guys can finish that. When you look at number 2, you have to remember that this is a right angle. So we're going to do the same thing. We already know 4 sides is 360. We already did that for number 1. We got 360. So we're going to go x plus 74 plus 90 plus 141 equals 360. Same thing here. Okay? When you look at this one, the measures of the interior angles of a quadrilateral. Again, we're doing 4 sides. We've got x, 3x, 5x, 7x. We know the sum is 360. So we're going to add 1x, 3x, 5x, 7x. Set it equal to 360. This one is harder. You're going to go ahead, solve for x. But the directions say find the measures of all of the interior angles. So you're going to take this x and replace it in the 5x. Replace this number in for 3x. In the x here to find the measure of each angle. Okay? Number 5, it says a home plate for baseball field is shown. We've got 90, 90, 90, and then these 2. These have one curve, so that means they're the same. These are 90s. Okay, we have 5 sides, which means we have 3 triangles. So your sum equals 5 minus 2 times 180. 3 times 180, 540 is the sum. Now when you solve this one, it says find the measures of C and E. We know this is 90, 90, 90. A lot of you guys then will just go 540 minus 270, get your answer, divide by 2. I'm going to write it out. 90 plus 90 plus 90. We know these are the same. They both have one curve. And then you're going to add like terms. And then finish solving it. Like the other one, when you get your answer, well, this one, you just plug the x's back in. Now the question, let's read it again. A home plate for baseball team field is shown. Is it regular? Regular means equal angles, all the measures are the same, and all the sides have the same length. Well, no, this is 90. These are not 90. So no. Angles, not all equal. Okay? They don't have the same measurement. I showed you how to do this. You just have to finish it. Okay, let's look at this one. Use the polygon exterior angle theorem to calculate. We said the sum for the exterior angles is always 360. Sorry. So you're going to add x plus 60 plus 64 plus 36 plus 48 plus x, set it equal to 360. You're going to add like terms and then solve the equation. Okay? Over here, and notice again, we only had one angle at each vertex, one exterior angle at each vertex. This one, we're going to add x plus 73 plus 109 plus 90. Okay? And it's always going to be set equal to 360. Okay, let's look at this one. This one's a little harder. Okay, we'll just do this. It says, find the measure of each interior angle. So this time, we're finding each interior angle and each exterior angle of a regular. Regular means all the angles have equal length. Equal measure, and all the sides have equal length. Okay, big deal that you know what regular means. So it is 24 gone. It is easiest on this. I'm going to show you two ways. Okay, for an exterior angle, the sum equals 360 degrees. Go back to when I was saying earlier, if we have, okay, 6 sides, that means we have 6 angles and we have 6 vertices. We also have 6 exterior angles, okay, because you would do one at each vertex. There's 1, 2, 3, 4, 5, 6. 6 sides, 6 angles, 6 vertices, 6 exterior angles. Okay? So we have a regular 24 gone, which means we have 24 exterior angles. If I want to know what each angle is, I'm going to, for each angle, so the sum is 360, right? When I add them all together, so 24 times each angle equals 360. So if I divide both sides by 24, that tells me what each angle equals. Okay, each single exterior angle. So I'll go ahead and punch in 360 divided by 24. So each angle is 15 degrees. Okay? So that means if I took 15, multiplied it by my number of sides, which is 24, because I have 24 angles, I'm going to get 360 degrees, which is always the exterior angle total, the sum of the exterior angles. Now, when we look at, let's look at these pictures up here. Exterior angles, add these together. Exterior angles, I'll come over, you're good. Add these together. Look, exterior angles always make a linear pair with the interior angle. Anytime, let me show you again. Let's see if I can do a better one. Okay? So if I extend here, this is my colors. Here's my exterior angle, right? And then I threw my pencil. Here's my, oh, I got it. Here's my interior angle. Okay, these together make, it's a linear pair that make 180. Okay, interior and exterior angles are linear pairs. So if my exterior angle is 15, then what would my interior angle be, right? So this is each exterior angle. So my interior angle, if it's a linear pair, you're going to go whatever, we'll call it angle, right, plus 15 is going to be 180. So if I subtract 15, my interior, because it is regular and they're all the same, the measure of the interior angle is going to equal 180 minus 15, which is 165 degrees. Okay? Now, if you wanted, you could have done it the hard way. And you could have gone ahead and gone 24, use your formula, okay? I'll squish it in here. The sum equals 24 minus 2 times 180. So that's 22 times 180. Okay? We could have done it this way if you liked it better. It's just a little more work. 22 times 180 is 3,960 degrees. This is for the sum of the interior measures of the angles. Is this much? Well, I know that I have 24 angles. So each interior angle will equal the sum divided by 24. So if I take this 3,960, divide it by 24, I'm going to get 165. You get the same answer, it's just another way to do it. Okay? That's good enough. You guys try and see what you got. Good luck. Here's my, kept meaning to put my owl on there and I forgot. Hope you have a good day. Thanks.